for decades, we've relied on this very specific, almost comforting metaphor for computers.
Oh, sure.
Like back in the early 80s, Steve Jobs famously called them a bicycle for the mind.
Right. The idea that a computer is basically a tool. It's an amplifier.
Exactly. You still have to pedal, you still have to steer, and, you have to actually know your destination. The machine just makes your human effort vastly more efficient.
Yeah, it was very human-centric view. The person is still entirely the engine of the operation.
Right. Well, wait. That was the reality until about 5 minutes ago.
Basically, yeah.
Because looking at the massive stack of sources we have for you today, it feels like that bicycle has suddenly morphed into like a massive fleet of self-driving corporate vehicles.
And you aren't pedaling anymore.
No, you aren't even in the driver's seat.
Yeah.
You were literally just standing on the sidewalk, pointing at a map and telling the fleet where to go.
It's wild.
It really is. So welcome to the Deep Dive. We're thrilled you're joining us today to unpack this completely industry-shaking shift. We have an enormous stack of technical updates straight from the desk of Andrew Kagan's weekly newsletter, dated March 2026.
And what is fascinating here is the sheer breadth of this update. I mean, we are looking at 8 distinct areas of enterprise tech.
It's a lot to cover.
It is. We have developments in Azure, Microsoft 365, Power Platform, DevOps, data analytics, security, new learning certifications, and just broader industry trends. But if you look closely, there is one unified architectural pivot tying every single piece together.
Right. We are tracking the aggressive leap from human-assisted AI to fully autonomous agentic systems. Like we're moving way past chatbots that just politely help you draft an email.
Oh, absolutely. We're talking about deploying independent digital workers.
Exactly. So our mission today is to decode how Microsoft is fundamentally restructuring enterprise IT into what they are officially calling the frontier firm.
Yeah, and the terminology Microsoft is using there is a huge signal. A frontier firm treats AI agents as digital colleagues rather than peripheral software tools.
Wow, colleagues, not tools.
Right, and that requires a complete redesign of how data flows, how code is written, and honestly, how security is enforced.
Well, let's start on the front lines then, the autonomous workspace.
Mm-hmm.
Looking at the updates across Microsoft 365, Power Platform, and Dynamics 365, we are staring right at Microsoft 365 Copilot Wave 3.
Yes.
And the defining characteristic here is this hard shift from the AI acting as an advisor to acting as an executor.
And that distinction is everything. I mean, an advisor gives you a rough draft, but you still have to review it, format it, and actually hit send.
Right. You're still in the loop.
Exactly. An executor takes a goal, finishes the task, applies the changes across your systems, and simply reports back that the job is done.
Which is terrifying and amazing. And driving this executor model is the new Copilot Cowork. What stood out to me immediately in the newsletter is that Copilot Cowork is actually powered by Anthropic's Claude model.
Yeah, that's a big deal.
It's a fascinating industry trend, showing Microsoft expanding its enterprise models far beyond just their traditional OpenAI partnership. But to manage these executing agents, Microsoft is dropping a new control plane called Agent 365.
And the pricing on that is really telling.
Let me give you the hard facts from the update, actually. Microsoft is launching the Microsoft 365 E7 Frontier Suite on May 1st, 2026. It's going to cost $99 a month per user.
Which is not cheap.
No. Or, alternatively, you can get Agent 365 standalone for $15 a month.
Right, and that $99 price tag for the E7 suite is not an accident. They are bundling the E5 security features, the Copilot Advisor features, and the Agent 365 Executor features all together.
I see.
They are no longer pricing this as a software upgrade. They're pricing it as a completely new class of digital labor.
Okay, let's unpack this, because my brain immediately goes to the practical reality of trying to deploy this in a super messy corporate environment.
Oh, the mess is real.
Right. Going from a naive intern you have to micromanage to a senior project manager who just hands you finished work. That sounds great in a brochure.
Sure.
But how does this autonomous agent actually know what my company's specific, highly nuanced, and, let's be honest, often entirely undocumented business rules are?
That is the million-dollar question.
Like, if I tell Agent 365 to process the new vendor contracts, how does it know our internal approval routing without me holding its hand?
And that is the exact friction point that the Power Platform and Dynamics 365 updates are engineered to solve. Because an AI cannot be a senior project manager if it doesn't have access to the company's historical memory.
Okay.
So Microsoft is integrating a system called WorkIQ directly with Dataverse, which is moving into public preview in April 2026.
Let's pause there for a second. Dataverse is essentially the underlying database for Microsoft's business applications.
Yes, exactly. It stores all the structured data for things like Dynamics 365. But WorkIQ layers on top of that to map your enterprise graph.
Okay, meaning what exactly?
It analyzes business relationships, past emails, historical project files, and the actual organizational hierarchy. It synthesizes all of that into a relational map that the agent can read.
Oh, wow. So instead of the agent just like guessing based on general internet training, it looks at work IQ and sees, the last time a vendor contract came from this specific supplier, it required sign-off from the VP of Finance before going to legal.
Exactly. It has the full context of your enterprise.
That is wild.
It is. But knowing the context is really only half the battle. The other half is outputting the work in a way that doesn't totally break your company's processes.
Right, because LLMs are inherently probabilistic, right? Meaning they essentially roll the dice to predict the next word.
Yes. That makes them creative, but it also makes them extremely unpredictable.
And unpredictability is an absolute nightmare when you are generating legal contracts or financial reports.
Which is why the updates to Copilot Studio are critical here. The newsletter highlights their new deterministic AI prompts for document generation.
Wait, how does a deterministic prompt actually work? If an LLM is a dice roller by nature, how do you force it to roll a 6 every single time?
You basically have to fundamentally change the generation parameters. In Copilot Studio, these deterministic prompts bypass the creative temperature settings entirely.
Yeah.
They clamp the output down to strict structural templates. So the model is forced to populate specific, predefined JSON fields rather than just freely generating text.
That makes sense.
Yeah, when you remove the human from the loop, you have to trade that creative variance for absolute rigid predictability.
I see the vision. You want the AI to like brainstorm like an artist, but execute like an auditor.
That's a great way to put it.
But, transitioning from human workspaces to autonomous execution requires a completely different kind of engine room.
Oh, absolutely.
We have all these front office agents doing the paperwork. Who is building the underlying tools?
The agents are.
Natural.
Yeah. And this requires flawless data pipelines and completely new developer workflows on the back end. The infrastructure basically has to adapt just as fast as the user interface.
Well, looking at the DevOps and SRE updates here, the mechanics are wild. The newsletter details GitHub agentic workflows, but the standout feature is the new Figma MCP integration in Visual Studio Code.
That one is huge.
Let's ground this for a second, though.
Yeah.
MCP stands for Model Context Protocol. What is that mechanically?
Think of MCP as a standardized universal adapter plug for AI.
Okay.
Historically, if an AI wanted to interact with a design tool like Figma, it had to rely on brittle, custom-built APIs, or it just had to look at a flat screenshot.
Which is super limiting.
Right. MCP provides an open standard that lets AI models directly plug into external datasets or tools and read their internal structures natively.
So it basically gives the AI structured eyes into the design file, and that creates this incredible canvas-to-code loop. Let's say a human designer creates a mock-up in Figma. The AI agent, using this MCP server, reads the actual vector data and design properties, translates it directly into Astro or React code, tests it, and builds a functioning web page.
Seamlessly.
But then it goes the other way in a code-to-canvas loop. If a developer or another agent tweaks the code in VS Code, the agent pushes those visual tweaks back to the Figma canvas so the designer can see the updated layout.
It completely dissolves the traditional wall between design and engineering.
It's unbelievable.
And while the front end is transforming like that, the data side is going through a similar revolution just to feed these agents. We have to look at the new Fabric AI functions, specifically a tool called Extract Label.
Right, because most enterprise data is trapped in unstructured formats. PDFs, clinical notes, thousands of messy customer feedback forms.
Exactly.
And parsing that used to require building incredibly fragile rule-based scripts.
And while LLMs are great at reading that unstructured text, relying on them to put it into a database is risky. They might hallucinate a new column name or just randomly change the formatting.
Which breaks the whole pipeline.
Right. Extract Labels solves this by forcing the LLM to output guaranteed schema-driven data.
Okay, so it locks it in.
Yes. It extracts the messy text and forces it into the exact tabular format your downstream data pipeline requires, locking the output structure before the generation even begins.
Wow. And the automation doesn't stop at data extraction. The Visual Studio Data API Builder now automatically generates complete REST and GraphQL APIs straight from a SQL database project.
Which saves so much time.
Just to quickly define those terms for you, REST APIs are like a restaurant with a fixed menu. You ask for an endpoint, you get exactly what's on that endpoint.
Nice analogy.
Thanks. And GraphQL is more like a buffet. You send a specific query and ask for only the exact data fields you want. Usually, setting those up requires a human developer writing hours of boilerplate routing code.
Oh, it's so tedious.
All right, now you just point the AI at your database, and it builds all the secure endpoints instantly.
It generates the configuration files, sets up the entity relationships, and securely exposes the data, just like that.
Here's where it gets really interesting. Let me push back here, because this is where I start getting genuine existential dread for developers.
I can see why.
If the AI is using MCP to design the front-end React code, A&D the AI is extracting the data schemas, A&D the AI is automatically generating the back-end APIs from the database. Am I, as a human developer, just a QA tester now?
Well,
Am I just sitting on the sidelines watching the front-end AI talk to the back-end AI? That feels like a massive demotion.
it definitely feels like a demotion if you view your value entirely through the lens of writing syntax.
Okay, fair.
But if we connect this to the bigger picture and look at the architecture of the frontier firm, the role of the developer is actually elevating. DevOps is shifting to context engineering.
Context engineering, meaning what exactly?
Meaning you are orchestrating complex agentic memory systems. When you have hundreds of autonomous agents interacting, someone still has to design the security boundaries, define the latency tolerances, and ensure the architectural logic holds together under load.
This is more big picture.
Exactly. You aren't laying the bricks anymore. You are the city planner. An AI can write a perfect GraphQL endpoint, but it doesn't intuitively know the broader business strategy of why that endpoint exists or how it impacts downstream legacy systems.
Well, I hear you. The value moves from the microscopic syntax to the macroscopic architecture.
Precisely.
But orchestrating that massive digital city running millions of AI to AI calls simultaneously requires an incomprehensible amount of cloud computing power. I mean, a local developer machine would melt trying to run this.
Which is why the underlying cloud muscle has to evolve simultaneously. Moving into the Azure updates, this is really where the raw compute power lives.
And the Azure developments in Kagan's newsletter are heavy hitters. Azure Databricks Lakebase has reached general availability. This caught my eye because it combines a managed PostgreSQL operational database with deep analytics capabilities in one platform.
Historically, those two things have always been aggressively separated.
Right.
You have your fast transactional database like PostgreSQL for daily operations, and you have your slow, massive data lake for historical analytics.
Right, and keeping them in sync meant building these incredibly fragile ETL pipelines, extract, transform, load, just to shuffle data back and forth.
It was a huge bottleneck.
Databricks Lakebase sounds like having your short-term memory, the transactions, and your long-term archive, the analytics, instantly synced. You don't have to hire a librarian to constantly move the books around anymore.
That's a perfect way to look at it. It removes massive latency from the system. And alongside that data integration, Microsoft is previewing Fireworks AI on Microsoft Foundry.
Oh, right.
This allows organizations to run high-performance, low-latency open models directly on Azure.
Because not every agentic task requires a massive, expensive frontier model like GPT-5. If you just need an agent to route a ticket or perform basic logic, you can use a smaller, incredibly fast open model, and Foundry gives you that flexibility natively.
Exactly. But all of this cloud muscle means the human workforce has to rapidly upskill. I mean, if you are listening to this right now and your career plan relies on building isolated machine learning models in a vacuum, you need to pivot immediately.
Yeah, the newsletter highlights 2 brand new certifications that specifically target this gap. The Machine Learning Operations, or MLOps Engineer Associate exam, which is the AI 300, and the Azure Databricks Data Engineer Associate certification.
These certifications are a flashing warning sign from the industry. Companies don't just need data scientists anymore.
Right.
They desperately need operations engineers who know how to deploy, maintain, monitor, and secure these generative AI solutions in live production environments.
And the word secure brings up the massive elephant in the room. When you centralize all your business data in Dataverse, and you give autonomous agents the keys to write code, modify databases, and execute tasks, you are creating an absolute security nightmare.
It is a terrifyingly rich target for cybercriminals.
No kidding.
If a hacker compromises an AI agent, they aren't just stealing a passive file, they are hijacking an executing engine that already holds internal permissions. Which brings us to the most critical theme of our deep dive: fortifying the frontier.
The threats we are seeing are getting highly sophisticated. The newsletter breaks down a new malware campaign called the Azure Backdoor.
This one is nasty.
It really is. It's targeting employees at financial and healthcare organizations using a brilliant and devious chain of attacks. The hackers start by flooding an employee's inbox with spam. Then they contact the employee on Microsoft Teams, pretending to be the internal IT help desk, offering to fix the spam problem.
It's classic social engineering, but weaponized through a trusted internal communication channel. People naturally trust a Teams message more than a random email.
Exactly. They trick the employee into opening a Windows Quick Assist remote session. From there, the hackers deploy the A0 backdoor malware using digitally signed MSI installers.
And that digital signature is the key.
Right. For context, MSI files are standard Windows installer packages. Because they are digitally signed, many basic security filters just wave them through as legitimate software updates.
Yeah.
But here's the craziest part. Once the malware is inside, it has to communicate with the hacker's command and control servers. To avoid getting blocked by enterprise firewalls, the malware hides its communications inside DNS-MX records.
The mechanics of that are incredibly stealthy. DNS is basically the phone book of the internet, routing traffic.
Right.
And MX records are specifically used to route email.
So imagine a corporate firewall is like a bouncer at a club. The bouncer meticulously checks everyone's pockets for contraband. That's inspecting standard HTTP web traffic.
Okay.
But the bouncer completely ignores the guy standing outside just asking for directions to the post office. That's DNS traffic.
Yeah. That's a great analogy.
Thanks. It's so essential for the internet to function that security tools rarely block it. The hackers are encoding their commands into the subdomains of these requests for directions, tunneling right past traditional network defenses.
It's brilliant. Terrifying, but brilliant. But Microsoft is deploying major defensive updates to counter this. First, they have Codex Security, currently in research preview.
Okay, what is that?
This is an AI system designed to hunt down zero-day vulnerabilities in open-source software.
Wait, how does it actually hunt them? Is it just looking for typos in the code?
Oh no, it goes much deeper than syntax. Codex Security uses AI to simulate the actual execution paths of the code.
Wow.
It models how memory is allocated and looks for complex logic flaws like buffer overflows or privilege escalation pathways before the code is even compiled into a live application.
So it's basically anticipating how a hacker might abuse the system.
Exactly.
They're also hardening the human endpoints, right? Microsoft is rolling out Entra passkeys to bring phishing-resistant, passwordless sign-ins to unmanaged Windows devices.
Yes, that's a huge step forward.
So even if an employee is logging in from a personal laptop at a coffee shop, they can use Windows Hello biometrics instead of typing a password that could be stolen over a fake Teams call.
And for organizations dealing with BYO being your own device policies, Intune has a crucial update. They're shifting to an opt-in mobile device management enrollment.
Oh, I saw that. This separates app-level access from full device takeover, right?
Right.
Instead of accidentally forcing a user's personal laptop into full corporate lockdown just because they checked their work email, the system secures just the corporate app container.
It respects user privacy while still maintaining the security boundary. But the most profound security update in this entire stack isn't software at all. It is hardware.
Oh, man. The new chip.
Yes. Intel has unveiled their new Heracles chip, specifically designed for fully homomorphic encryption, or FHE.
The specs on this chip are staggering. It operates at up to 29.5 TOPS tera operations per second. Just to ground that for you, a standard chip measures its AI-specific operations in a fraction of that.
Yeah, it's massive.
So we are talking about dedicated mathematical horsepower. And it performs FHE math operations up to 5,547 times faster than a standard 24-core Intel Xeon chip.
To understand why FHE requires that much horsepower, you really have to understand the core vulnerability of cloud computing.
Okay, break it down.
You can encrypt data while it sits on a hard drive, and you can encrypt it while it travels across the internet.
Right.
But the moment the CPU actually needs to process that data, like to run a search or calculate a sum, it has to decrypt it into plain text inside the computer's memory.
And that split second of decryption is when hackers strike using memory snooping attacks.
Correct. Fully homomorphic encryption solves this entirely. It allows the processor to perform complex mathematical operations on the data while it remains completely encrypted.
So what does this all mean? I mean, I understand the concept of a locked safe, but if the data is locked inside a steel safe, how does the AI actually read the text to do the math. How can a CPU calculate numbers it literally can't see?
This raises an important question, and it's counterintuitive. It doesn't read the text.
Okay.
FHE works by translating your original data into an incredibly complex mathematical representation, essentially algebraic noise.
Noise.
Yes. The CPU performs its operations on that noise. It manipulates the encrypted structure itself. Imagine having two locked boxes containing gold. You don't need the key to open them to know which one is heavier. You just put the locked boxes on a scale.
Oh.
FHE allows the CPU to calculate the weight of the data without ever seeing the gold inside. When you finally decrypt the result on your local machine, the answer perfectly matches the computation, even though the cloud server never knew what it was calculating.
That is mind-bending.
It really is.
If the data is never decrypted in memory, it eliminates entire classes of hardware and side-channel attacks.
Yeah.
Even if a nation-state hacker completely compromised the physical server rack in the Azure data center, they would only walk away with mathematical gibberish.
Exactly. You don't even have to trust the cloud provider anymore because they literally cannot see your data.
The cloud becomes inherently zero trust at the silicon level.
Wow. And we are seeing this kind of radical optimization in broader industry trends, too. Cloudflare recently published a report detailing how they are slashing agent token costs by 98% using RFC 9457 compliant error responses.
Okay, RFC 9457, that is a standardized way for API to report problems, right?
Yes. So instead of a firewall serving up a complex, human-readable HTML block page that an AI agent has to burn expensive processing tokens to read and understand.
Which wastes time and money.
Exactly. The firewall simply sends a lightweight, machine-readable error code. The agent instantly understands the block and moves on.
It perfectly illustrates the maturity of this space. Security protocols and AI efficiency are just evolving together to support this massive agentic boom.
They absolutely are.
It really is an unbelievable time to be in this industry. Taking a step back and looking at this entire stack from Andrew Kagan's newsletter, we've covered a massive amount of ground today.
We really have.
For you, the listener, the takeaway from all this is pretty clear. The paradigm has permanently shifted. We are moving decisively from a world of passive tools to a world of autonomous digital colleagues. From the visual design canvases of Figma all the way down to the mathematically encrypted silicon of Azure servers, the frontier firm is no longer a concept. It is here.
And it leaves us with a profound shift to consider. We are entering an era where Agent 365 governs your digital workforce, Fabric AI perfectly structures your corporate data, and Visual Studio Code agents automatically write your backend APIs.
If you project that out just a few years, the enterprise of the near future will absolutely have more autonomous agents running around than human employees.
Which brings us to a final, slightly provocative thought for you to mull over.
I love these.
If the friction of actually executing a task drops to zero, if the code writes itself, the data organizes itself, and the signs build themselves, what is left? Will your ultimate competitive advantage in the marketplace simply be the quality of the questions you ask?
Wow. We started this deep dive talking about computers as a bicycle for the mind. But if the AI is doing all the pedaling and, even plotting the route using an enterprise graph, your only job left is deciding what destination is actually worth traveling to. Thank you so much for joining us on this deep dive. Keep asking great questions, and we'll see you next time.